So in the last video, we have seen how to find the roots of a quadratic equation by graphing the associated quadratic function. In this video, we will see how to find the solution of a quadratic equation by a well-known method called factoring method. For that, we will define one new form of a quadratic function, that is intercept form. What is an intercept form? If y is equal to fx, which is a quadratic function, is written in this form: a times x minus p multiplied by x minus q, where x minus p and x minus q are called binomials, okay, where this p and q are nothing but x-intercepts of the quadratic function. So essentially what you have done is, you have seen a graph of a function and you have located the two intercepts, x-intercepts of the function. Whenever the expression is possible in this form, you are writing it. So y is equal to a x minus p into x minus q, and this form is called the intercept form. So let us try to see one example of intercept form, which is, let us say you have been given this intercept form: y times 3x minus 1 x minus 5, and you also know that these 1 and 5 are x-intercepts of the quadratic function. That means you have been given two values. Can you find the third value? The answer is yes. So at point 1, when x is equal to 1, the value is 0. At point 5, the value is 0. Now, using the logic that I gave you in the previous video, you can actually see that there will be some axis of symmetry between this 1 and 5, because 1 and 5 both take value 0. Right? So the axis of symmetry will be nothing but the distance between these 2 points divided by 2. So 1 plus 5 divided by 2, 1 plus 5 divided by 2 is 3. I am sorry, it will not be a distance, it is just the sum of these 2 points divided by 2, average of these 2 points. That should be the correct terminology. So it should be average of 2 points. So 1 plus 5 divided by 2 is 3. Now x is equal to 3 will be the axis of symmetry for this particular function, if at all these are the roots of these are the x-intercepts of the function. So now I have given you x is equal to 3 is the axis of symmetry. So just substitute the value 3 in this particular graph, in this particular equation, and you will get 3 minus 1 is 2, and 3 minus 5 is 2, minus 2, that means 2 into minus 2, minus 4 into 3, minus 12. So you got 3 values. What are those 3 values? 1, 0, 5, 0, 3, minus 12. So based on this information, you can easily plot the graph, which will look like this. As you can see, this is the value minus 12 here, value minus 12 is here, and 0, 0. So you can easily plot this graph, you can connect the smooth curve using this. Now the main question is, once given this kind of expression, how to convert this expression into a standard form. So that is the question that I will pose now. How will you convert the intercept form into the standard form? Just by multiplying the two binomials. So for multiplying the two binomials, we have one rule which I will state in the next slide. So the conversion from intercept form to standard form will happen using a method called FOIL method, which is described below. So the product of two binomials, as I already mentioned, that x minus p and y x minus q, these are the two binomials. So the product of two binomials is sum of the product of first terms, the outer, the inner, and the last terms. So let me make it more precise by demonstrating it. So let us consider this expression, which is ax plus b into cx plus d. Now ax plus b into cx plus d, what I will do is, I will first take the first term of this expression and the first term of this expression, and multiply them together. That is the first term over here. By the sum of the product of the first terms, I mean this term. Then I will take the inner term. Okay. Then I will take the outer term, sorry. Then I will take the outer term, that is B is the outer term here. Sorry, not B is not the outer term, B is the inner term. You have AX, which is the outer term, and D, which is the outer term. So now you just multiply them together, which gives me AX times D, which is the outer term, product of the outer term. Then you take the inner terms, that is B and Cx. So B into Cx, this is the inner term, and B into D are the last terms. First term, outer term, inner term, and last term. That way we will multiply these things together. That means I will get the first term as ACx square. Second term is AD plus BC times x, and the third term as BD. Now if you look at, so basically the AC is the term which is the coefficient of x square, AX plus BC is the AD plus BC is the term which is the coefficient of x, and BD is the term which is the coefficient which is the constant term. Right. So now a quick observation you can make is, if you look at the product of this first term and the last term, what will you get? AC into BD, so it is ABCD. The product is ABCD. Right. So the product of the coefficient of x square and the coefficient of constant is ABCD. In a similar manner, if you consider the coefficients of x, AD and BC are the coefficients of x, AD plus BC. So if you take product of these two terms, again it will be ABCD. This is a crucial observation which we will need while converting a standard form to intercept form and vice versa. Just remember this, the product of the coefficient of x square and the coefficient of constant is ABCD, and the product of the two terms of the coefficients of x is ABCD. Both of them are ABCD. So this we will use to convert our expression into standard form and convert our expression in intercept form in various ways. So that observation is very crucial for us. So let us take one example and see how we can apply our knowledge which we have gained in this particular video along with the previous videos to solve this problem. So the question is, write a quadratic equation with roots 2, 2 by 3 and minus 4 in the standard form. Okay. So let us recollect what is a standard form. Standard form is of ax square plus bx plus c equal to 0, and a, b, c all are integers and a should not be equal to 0. This is the standard form. We have already seen that. Okay. So now if I want to write this, we will use our knowledge about intercept form, and we can easily write this expression as x minus 2 by 3 into x plus 4 is equal to 0, because 2 by 3 and minus 4 are the roots. Yes. But this equation is not in the standard form. So now in the previous slide we have seen that in order to convert this into a standard form, we will use a FOIL method. So let us try to use a FOIL method. So the what is a here? Ax plus b, that is a is 1, b is minus 2 by 3, c is 1, d is 4. Okay. Now you use FOIL method, that is first terms. So first terms is 1 into 1, so it will retain 1x square. Then AD plus BC, so minus 2 by 3 into 1, and A is 1, 4, 4 minus 2 by 3, that is the product here, minus 2 by 3 plus 4. This is the term which has coefficient of x, and then minus 2 by 3 times 4, which is the term here. So this is successful application of FOIL method. Now let us rewrite all these things. That is, you can sum this and write the sum, that is x square. So 4 3s are 12, 12 minus 2 10. So x square plus 10 by 3 x plus minus 8 by 3. Right? Is this equation in a standard form? No, because for standard form a, b, c all must be integers. So what I will do is I will multiply this equation with 3 on both sides. So if I multiply on both sides with 3, then I get 3x square plus 10x minus 8 equal to 0. That is the solution to this question. So the quadratic equation in standard form is 3x square plus 10x minus 8 is equal to 0. So we have solved. Let us now go further and try to see how I will convert a standard form into an intercept form. Again, we will use FOIL method but in a reverse manner. So I want to convert a function, quadratic function, which is given to me 5x square minus 13x plus 6 to intercept form. That means I want to write a times x minus p into x minus q. So how will I convert this? So what I will do is I will take this particular function 5x square minus 13x plus 6 and apply FOIL method to it. How to apply FOIL method to it? I will equate this to be equal to ax plus b into cx plus d. Then based on FOIL method I have this expression, which is ac times x square ad plus bc times x plus bd. Now remember, we have done some observations, that is the product of this and this is ABCD, correct? So now I can equate this equation with this equation. So term containing x square will be equated with term containing x square. So I will get AC is equal to 5, AD plus BC is equal to minus 13 and BD is equal to 6. Then from this expression I can also derive an information, that is ABCD, that is the product of the first and the last term and the product of the terms contained in the sum is 30. So 5 into 6 is 30 and AD plus BC is minus 13. Now my job becomes crucial. My job is to guess what those two terms will be, AD and BC. Right? So that their product is 30 and if you sum over them, then it must be minus 13. For that I will use the prime factorization theorem that was introduced in week 1. So if you look at this expression 30, I will get prime factors as 2 into 3 into 5. Now I want the product to be equal to 30 and I want the sum to be equal to minus 13. So based on this, what I can derive is, if at all this term has to be negative, I should have some negative factors over here and both of them should be negative factors. In particular, if I combine 5 and 2, I will get 10 and 3, and 10 plus 3 is 13, but it is not giving me minus 13. So I will use a trick that multiplication of two negative numbers will become a positive number. So it is minus 10 into minus 3, which will give me 30. At the same time, the sum will be minus 13. So that means my AD is minus 10, BC is minus 3. It doesn't matter, you can switch also. You can write BC as minus 3 and AD as minus 10 also, it doesn't matter. So now I will substitute these values into this expression. Essentially I will rewrite this expression. So I will write this expression as 5x square minus 10x minus 3x plus 6. Okay. Then what I will do is I will look at the first two terms and I will take the greatest common factor from these two terms, that is 5x. So I will take 5x, whatever is remaining I will put in a bracket, that is x minus 2. Here also I will take the greatest common factor out, that is minus 3. So minus 3 into x minus 2. Now you can see these x minus 2's are same. So essentially this expression will come if I have 5x minus 3 into x minus 2. Now, is this in the intercept form? No, still it is not in the intercept form. What is the intercept form? It is 8 times x minus p, x minus q. So, I will just divide everything by 5 in this expression and take the 5 out. So, 5 into x minus 3 by 5 into x minus 2, this is the intercept form. So, using FOIL method, I have converted this expression into an intercept form. An expression was given to me in standard form, I have converted it into intercept form. Let us see few more examples, as this concept is quite intricate. You may need some practice. You solve as many problems as possible, but I will give you some demo cases so that it will be easy to distinguish for you. So let us say you have been asked to solve this equation. X square is equal to 8x. Now here you don't really need a FOIL method. What you need is just rearrange x square minus 8x, and you just take out the greatest common factor, which is x. So x, this will give you x into x minus 8. So if I want to solve this, I know x minus 0 and x minus 8 are the things. So 0 and 8 are the roots of this given quadratic equation. Simple. This solves our problem for such a simple case where the constant term is absent. Right? Now let us take another example. X square minus 4x plus 4 is equal to 0. Now in this case, you will use FOIL method obviously, but the essence of FOIL method reduces to that the coefficients of x are of the form AD plus BC, and the product of this and this is ABCD. So the product ABCD is 4 and AD plus BC is minus 4. This is what it reduces to. Okay. So if ABCD is 4 and AD plus BC is minus 4, is there any other way out? 4 can be factorized only in one way, that is 2 into 2, 2 into 2, and AD plus BC is minus 4, that means both of them should be negative, minus 2 into minus 2. So AD is minus 2, BC is minus 2. Substitute it in the master equation where you can write x square minus 2x minus 2x plus 4. So you have substituted it in master equation. Now you go ahead and take out the greatest common factors out. The first expression will have x out, the second expression will have 2 out. Then again these are product of binomials. So it will be x minus 2 square, which is equal to 0 given in the expression. So what is the root of this equation? 2. 2 is the real repeated root of this equation. Let us go ahead and solve one more example. X square minus 25 is equal to 0. This is quite interesting. 25 you can see is a perfect square, 5 square. And I want to find the root of this equation. Again I will use FOIL method. ABCD is minus 25 and AD plus BC is 0. Right? 5 is a perfect square. So 5 into 5 is the factorization, but minus 25 is there. So one 5 will be with a positive sign, another 5 will be with a negative sign. So AD can be plus 5 and BC can be minus 5 or vice versa, it doesn't matter. Substitute this knowledge into this expression. So you take x square minus 25 minus 5x plus 5x, take out the greatest common factors, that is x and 5 respectively. You will get this kind of expression, and then you just rewrite them as product of two numbers, that is x plus 5, x minus 5 is equal to 0, and you have solved. Remember, in all these expressions we have written this in intercept form. So all these expressions are written in intercept form. Once you write an expression in intercept form, it is very easy to find the roots of the equation. Or in fact, once you write in the intercept form, you have already figured out the roots of the equation.